All right, welcome everybody. It's great to see all you guys. Thank you so much for coming to my talk. My name is Kevin Jones. I am a developer relations engineer working for Edge and Node, working on the Graph protocol. I am also one of the members of the Build Guild, working on Scaffold-ETH. So this talk is actually kind of like geared at both subjects, but more importantly, we're going to be talking about how to build a subgraph with Scaffold-ETH, and also how to build a subgraph with a studio. It's going to be a bit of a speed run, so I hope you guys are ready, because we're not going to do a lot of slides and a lot of talking, and it's going to be actually like setting everything up. So this is kind of what we're going to build. Basically, Scaffold-ETH is a toolkit that you probably have heard of. It's got everything you need to basically build a Dapp really quickly. So it's really good for hackathons. It's really good for prototyping. And there's a direct integration called the subgraph package, which is available as a branch in GitHub that we're going to use. The value add here is that we're going to use NextJS as our front end. So for React with NextJS, we're going to use Hardhat for our backend for writing a smart contract. And then we're going to use the graph as a middleware layer to basically do all of our indexing. The reason we want to do this is because really the Ethereum blockchain is not ideal for reading data. You have this issue where it's not easy to interface with the JSON RPC. And so you really need something like the graph to do that. And that's the value proposition for what we're going to do. I only have one more slide, and this is what the graph is. So if you haven't heard of the graph is a decentralized indexing protocol for a lot of different blockchains, Ethereum one of those. And it essentially takes the design theory where you build a Dapp, and instead of querying for data from the smart contract via a JSON RPC, you write your transactions like you normally would via the normal blockchain. And that's incentivized for writes, really. And as your smart contract emits events, those events are picked up by Graph Node, and those are indexed using a WASM module that's written in assembly script. This is then stored on Postgres inside of a database running on the indexers, and then it's exposed with a GraphQL API. So the value is that you can utilize GraphQL for blockchain data, right? That's the only two slides I got. We're just going to kind of dive in. So, Scaffold-ETH is an open source toolkit. It's available on GitHub. You can go to Scaffold-ETH.io. You can basically, there's two ways to install Scaffold-ETH. You can install it with Git, or you can install it using NPX. NPX is in beta. And if you want to do this subgraph package, you're going to want to use Git because it's a special branch. And right now, there's no way to set up the graph with the NPX way. So you're going to want to just click on the GitHub link right here. And when you come here, you can see Scaffold-ETH. So you can see here, this is the main branch. It's got like all the kind of walkthrough, the README, how to set it up. But then there's a special branch right here called subgraph package. So you can just select that. And this is going to be a special branch of Scaffold-ETH that comes with the graph. So it's the same, it's pretty much up to date with the main branch of Scaffold-ETH, but it's just got an additional package called the subgraph package. So I've gone ahead and I've basically already checked out the repository. I'm using tmux, which is a terminal multiplexer, so it just allows me to give 3 windows open here. Everything you do in Scaffold-ETH, you kind of have a few windows open, so that's why I've got 4. We're going to need 1 for our back end. We're going to need 1 for our front end. We're going to need 1 to do deploys, and then we're going to need 1 to run the graph infrastructure that I just talked about. So we can set this up. If you do a Yarn install, it's going to go in there. Once you check out the package, it's going to install all the requirements that you need. Okay, that takes anywhere from a minute to 2 minutes, depending on your internet connection, and then you're pretty much up and running. Then you can do a Yarn chain. So Yarn chain is going to do exactly that. It's going to spin up your chain. If you're using the subgraph package, that's Hardhat. If you use the npx command, that could be Foundry. If you do choose, there's an option for that. But for this sake, we're going to be using Hardhat. So it spins up Hardhat on localhost, and it also gives you all of your accounts, like to basically play around with fake ETH, right? Then what we can do is in the second window here, we're going to do Yarn start. So this is going to spin up a React with NextJS. And pretty much all the code base is in NextJS. It uses app router. And it also is written primarily in TypeScript, but it also does support JavaScript if you want to write in JavaScript. But as you can see, it's nice and snappy, super fast, right? We're up and running. So we're always going to keep kind of those windows up. The next thing we can do is we can do a deploy. So As you can see, everything's kind of like around these yarn commands to make it easy. So the next one is to yarn deploy. So yarn chain to spin up your back end, yarn start for your front end, yarn deploy to take your smart contract that's in the package and deploy it. So it does come with the smart contract that we're going to look at in a second. And you can see that we got our deployment basically was successful. We can see the address for it. We can see that it created the types in TypeScript. And the cool thing is it actually, as you deploy your contract, it injects the ABI into Scaffold-ETH as well, which I'll show in a second. And it gets you kind of up and running. The last thing that we want to do is spin up the graph node infrastructure. So on top of the front end and the back end, we also want to spin up the stack for graph node. So the stack for graph node, we just do yarn run dash node. So this is going to be all running in Docker. So you need Docker installed on your machine. Obviously, when you want to ship to like a testnet or to like mainnet Ethereum, then you can move it to the decentralized network. If we have time, we're going to deploy a contract there as well. But you can see here that the graph node is basically coming up. You can also see that IPFS is coming up, and you can also see that Postgres is coming up. So that is the stack for the graph. It is graph node, which is written in Rust. It is Postgres, which is for the database, and then it's IPFS for all of the configuration files and the manifests, right? So that's it. So we were able to kind of, with these 3 windows, set up a complete environment for doing some local development, okay? So let's go back to our browser, and let's go to localhost 3000, which is where Scaffold-ETH is running, right? So Scaffold-ETH, again, it is a React app. You can see here that we've got Scaffold-ETH up and running. It kind of gives you some hints on how you can get started editing your application by going to page TSX. Tells you where your contracts is located. And then really, what's really cool is this debug contracts folder. The debug contracts basically is automatically generated based on your smart contract. So if you make a change in your smart contract, redeploy it, you will automatically get all of the read and the write functions and all of the reads for your variables as well. So we can instantly know what our contract does without even looking at the smart contract. It's a very basic contract that has a read to get a counter. It has a write function to basically write a greeting, a new greeting, and then it has a section to add value to the transaction as well, and it has a function to withdraw funds from the smart contract. And then it has a greeter called Building Unstoppable Apps. It has an owner variable that's set up, so it has some kind of like access control out of the box, some booleans and a counter. So we could come in here and say, all right, biddle week like this, and hit send. It's going to basically tell me that I don't have funds to pay for this transaction. Okay, out of the box, you'll notice too that we don't really need to connect to MetaMask because we have a burner wallet in the top right corner. So you can see here that it's actually empty, doesn't have any ETH, so I don't have any gas to pay, but I can just hit this little button right here and get some funds from the faucet. So I'm instantly able to do that again and then hit send, and then now we can see that that state variable was updated, right? So really easy, we can start prototyping. So let's take a look real quick at the code base so that you guys can see what it looks like, okay? It is a mono repo. So what that means is that you have a base yarn package repo, and then inside of that packages folder, you have like sub repos, like repos within that main repo. And so we have 3. We have Hardhat, which is our chain. We have NextJS, and then we have the subgraph, okay? So if we go to Hardhat and we go to contracts and go to your contract, we can see that contract. So here we have a contract that's basically called your contract. It has that string that is the greeter function right here. And then it has an event that gets emitted every time that the greeting changes, okay? And that's the important thing that we're going to talk about right now. And it also has a function here that allows us to set a greeting by taking it in as a new value, right? So that's what allowed me to make my change on the front end right there, right? So let's say now at this point, we wanted to be able to see the data for these. We've made some transactions, and we want to actually see that data, right? How do we get that data? Well, normally you would need to have a listener, and you would need to subscribe to all the events that are happening on your smart contract. But in this case, we don't want to do that because that's a little inefficient, because we would need to loop over and create some kind of for loop to get all that data. So we're not going to do it that way. We're actually going to use the graph. So if we go back to our package, and go to the subgraph package, we can look at what the subgraph looks like. So as we have a subgraph, we have a smart contract that is already written for us. We also have a subgraph that's already written for us. So out of the box, you have one here that is exactly matches what needs to be for your smart contract. And so really a subgraph is 3 files. It's the manifest, which is this kind of like main YAML configuration that we're looking at now. It's a schema, which is basically how you want to store that data and organize it, which is written in like GraphQL. So if you're familiar with GraphQL, you've probably seen this before. And then you have a mappings, which is the assembly script that is compiled down into WASM to process the data. So this high-level subgraph YAML is basically telling you, OK, well, what network do we care about? So this is localhost, right? What contract address do we care about? It's right here. It's also injected when we do a deploy. Well, what entities do we care about? Well, we want to track the greetings as they change, and we also want to track the senders, like who actually sent the greeting. And then we also want to tell it exactly what handlers to run, right? So this is what needs to happen every time that an event happens. So here we're going to say, OK, here are our entities, and this is what should happen every time that this particular event is fired off, OK? So we're going to say here, handle this event and process these data types. So we can see here we have a greeting change. It has an address, string, Boolean, and an unsigned integer. And those match exactly what is inside of our smart contract. Our smart contract. So if we go to the event, that's exactly what we see here in these values. So what we can do is take this subgraph and take this mapping module, and we can deploy it to the graph node infrastructure. So we can do that also with simple yarn commands. So we can say yarn local-create, which will, you only need to run this once, but what it does is it takes your subgraph and it deploys a instance of it on your graph node instance. And you only need to do that once. Then you just need to do yarn local-ship. And what this is going to do is it's going to read in the subgraph configuration. Again, it's already written for you. It's going to compile it down. It's going to check to make sure there's no errors in it. And then it's going to ask you to deploy it. So you can see here we have this, sorry, that might be hard to read, but on the very bottom, there's a version that it wants to know. So just like you make changes to your smart contract, you also need to make changes to your subgraph. And because your smart contracts evolve, they add new events. You also need to add new events to your subgraph. So this version might change. We can just do 1. Now it's going to take the subgraph and deploy it. So now we can see here that our subgraph is taking the data from Hardhat, and it's pulling all that data and dumping it into Postgres for us in the back end. So, and it's also going to give us a query URL, which is right here. So we can grab that query URL, and we can load that up on our browser, and we can start looking at the data. So if we go to Explore, the cool thing about GraphQL is GraphQL gives you the ability to kind of like, you already know what the data is going to look like based off the schema, which is here. And we can see that there's 2 entities, greetings and senders. And so if we come here to Explorer, we can start to explore that data. Again, this might be hard to read. Let me zoom in. But you can see here we have greetings. So let's go to greetings. And we can say, OK, well, I want to get the first 5 or first 10 greetings. I want to order them a certain way. We can do it by the transaction date or created at. We can do it order ascending or descending. We can choose what we want to get. So we can get the greeting, the ID, the premium, whether it was paid, how much value, and then we can hit play. And then we can get this data back in a single query. So this is a lot more efficient than having to do a listener, where you're actually like having to pull the JSON RPC over and over and over and over and over again to get the data. Instead, we can just do one simple HTTP query against the graph node instance and get back that data. Okay? So this data, as you can see, it's the first 10 that I did. I kind of spammed it at the beginning, and we can basically load that into our front end. So if we look back here, I want to touch base on this real quick too. So what's the magic? What's the magic that's doing this? Well, it's really this assembly script code. This is kind of like the power to like how the graph works. What it's basically doing is it's ingesting all of the ABI. And it's basically creating types to basically interact with those using GraphTS. And then it allows you to do things with those. So you can see here we have one handler that is called handle greeting change. And if we look back at the subgraph YAML, that's what's referenced here. So if we go to the mappings again, we can see that what happens is every time there's an event called greeting change, we check to see what the sender is, the sender string, and then if it's there, it basically loads it in based on the string. If it's null, it basically creates an object here, and it sets all the data for those the key values. So in this case, we have the sender, the message sender, the address of who actually set the greeting, when it was created based off the timestamp from the Ethereum block, and then the counter, which is 1. Now, if this already existed in the database, then it would actually increase that counter by 1, right? So it's doing some logic here. And then we also do the same thing with the greeting. We create a transaction, basically ID, and then we load in all the parameters from the event here. So the greeting, the sender, the premium, the value, the timestamp, and then we put the transaction hash as a hex value, and then we save it. So like these last 2 steps is basically where it's saved inside of Postgres on the indexer. Now, this is all local development, right? What we could do is we could then deploy our smart contract to an actual test net or to a main net, and then we could create a subgraph from there. So that would be the kind of like the next steps. The other thing I just want to show off too is like NextJS. If we go to NextJS, we're using the app router version of NextJS, and you can see that there's a subgraph section here. And if we go back to the UI and go here, sorry, here, there's this subgraph tab. And we can see it's kind of the same kind of hints, tells you how to start the node, how to create it, how to ship it, and how to clean up data if you want to like reset everything. But what's more importantly is down here on the bottom, we have a table that is basically indexing that data. So if you want to kind of see what it looks like to put into your front end, you can reference this subgraph page that's here. And it kind of shows you exactly how it's getting the data. It's basically a component that is making the query, which is here, formulating the query. It's using GQL and useQuery to basically get that data back. If there's no data, then it just displays nothing. If there is data, then it kind of parses that and displays it in a nice, pretty table. So yeah, really easy out-of-the-box experience. Now, as you start getting more into subgraph development, you might make some changes. What I would recommend that you guys do is go to thegraph.com and go to products, and you can go to Subgraph Studio. And you can create a subgraph on any contract that we support. So you can just say create subgraph, name it whatever you want, like Biddle, hit create subgraph, and it's going to give you all the instructions you need to create a subgraph from this portal. So this is very useful because if you, let's say you want to use, like earlier I did one on the Buffacorn Biddle Brigade, so I have it here deployed. We can take a look at it. I indexed the Buffacorn NFT contract, and we can see that I did it 7 hours ago. It's fully synced, all the data's there, and now I can go to the playground and I can do the same thing. I can say, all right, well, let's get the events for all of the transfers. So I can say, all right, what are the transfers for the first 10, order by transaction timestamp, and order descending. And then actually, let's just grab the very first one. And let's get the to and from and ID. And you can see how easy it is to get the data you want and hit play. And then so now we can see that the very first, based on timestamp, descending data for a NFT being transferred was here, which is 4210. It's the token ID. So it's a really seamless experience, developer experience, to basically create a new subgraph from scratch. There's also other subgraphs. So you can go to Subgraph Studio. You can go to Graph Explorer. And there might already be a subgraph. So if you're like building, let's say, a DeFi aggregator, or you're building like a no-code or like a dashboard or something for DeFi, you might search for a specific subgraph. So the most popular one is Uniswap. We can click that, and we can start to get interesting data about Uniswap. You can also see sometimes that there is a link to the source code so that you can go there and see how it works. You can look and see how a subgraph is created on their end. And then, then you can start exploring the data here. And then from there, you might get to the point where you actually want to signal your subgraph, put it on the network, and then it would be picked up by the decentralized network. And so the value proposition here is that the graph aims to make data for blockchain truly decentralized by distributing all this data across the blockchain, the indexer network. And yeah, so I hope that was useful. And I'll be here to answer any questions that you guys have, because I only have 12 seconds left. But I hope that was useful. Thank you, guys.